is equal to omega A. The radius of A is 0.01. Divided by the radius of B is equal to 0.025. So this will be equal to 1320, 528 radians per second. Okay. So we know gear B, if we go back to the question again, we know that gear B, okay, so we have determined the angular velocity of gear what? Of gear B, okay. The next thing is we have to determine the angular displacement of gear B also, okay. So to find the angular, so part B, I'm going to write the next part. Next, we have to determine determine the what will we ask to determine? Sorry, the angular displacement of gear B, right? And remember what we have written before is theta A RA is equal to what? Theta B RB. Okay, so this is also our gear equation. So somehow we also need an expression, right? To get our, so next we have how to determine, before we can use the gear equation, how to determine theta A, right? So I'm going to write by the side over here so I won't be spinning and losing pints of beer. Okay, so we're going to continue on over here, how to determine theta A. So we have the equation, right? We have the equation where omega is also equal to 150 t cubed plus by 60 t. Okay, 150. So we have omega equal to 150 t cubed plus by 60 t. Now this is directly from here after we integrate, right? So we are aware that omega is equal to d theta over dt. So this is omega A. This is also omega A d theta A. So from here, we can determine theta A. So what we need to do now, so we know that we are going to integrate, or I rewrite the expression. So d theta A is equal to omega A dt. Okay. So now we have to integrate over here 0 theta A, okay, d theta A. This will be equal to omega A. We have to integrate 0. Time needed is 2. Then we have 150 t cubed plus by 60 t. And finally, we do dt. So theta A is equal to 150, or 150 divided by 4 is what? 150 divided by 4 37.5. T4 plus by 30 T squared, and this is 0 to 2. So therefore, theta A will be equal to 2 power 4 times 37.5, 600 plus 120. So this is equal to 720 radians. Okay. And finally, we know the expression theta B RB is equal to theta A RA, right? So therefore, theta B is equal to 720 multiplied by 0.01 divided by 0.025. It's equal to 288 radians. Okay. Are we clear? Okay. So much more interesting than constant what? So much more interesting than constant acceleration. This is more difficult than vibration, don't you think so? How many of you find this more difficult than vibration? Yeah, I think we are the few only weird ones, okay? I so much enjoy vibration, but this is good. Are we clear? Okay. So key things to take note, okay? Once you are given a question like that, try to write out the expression, okay? Try to do your side work. Then from your side work, then you can visualize what formula to apply, okay? Right. So the next example that I like to do is now a pulley system. Okay, so we are going to do example number 2. So let me ask you, have you guys learned gear ratio, those in year 2? Are you doing gear ratio in your mechanical design yet? What are you doing in mechanical design? Huh? Oh, so you know that power equal 2 pi nt divided by 60, right? No, it's okay. Okay, when we get there, okay? Right. Example number 2. So I like to mention this, the examples that I do are always the more difficult examples. Okay, I don't do easy examples. By looking at the more difficult examples, doing the homework where the questions are easier, you should be able to solve them better. Okay, I hope that. Okay, so the examples as said I'm doing now are not so straightforward. It is quite a bit of information that's given. Okay, so the next example. It's a pulley system. Okay, so we are going to. The first time I look at it, I say, oh, really? Right. So again, you ask yourself, is this planar? And what are the rigid body? How many rigid body do you see down here? There are 2 rigid bodies. Okay, they're in motion. One is motor A, the other one is pulley B and C. If this thing is under motion, point D and point C, will it change in terms of distance? No, right? Okay, so over here, the motor itself is a rigid body. Why is it a rigid body? Because from the axis of rotation and at the point where the belt contact, where I draw the other dot, that distance will never change. Rigid body. For this case, at point D at the center to the rope and to point C, when this whole thing is rotating about this direction, this distance will never change. So again, that's where I'm teaching you all how to recognize it is a rigid body or not. For this case, it's confirmed rigid body analysis. And then if we were to draw the transformation, X, Y, and then we have rotation about Z, and we are aware that the motion is in which plane? XY plane, yes or no? So over here, we are aware that the motion is in XY plane. Okay. Okay. Let's look at the problem. Okay. So problem like this can be overwhelming because there are two things that's happening. The pulleys are rotating, yes or no? Right? So you have seen pulley before, right? So you have a pulley. So, however, the weight at B is under what? Okay, the weight at, okay, the pulley and the motor are under what sort of motion? Rotation about a what? Okay. The weight at point B is under a rectilinear motion. But you know the relationship. Okay. Right. So let's read the question. Starting at omega A. Okay. So omega A. So over here, this is our omega A. We're going to start at 3 radians per second. Okay. So omega A. This is going at 3 radians per second. And it specifies that theta is equal to 0, S is equal to 0. So we know theta, the rotation is equal to, so, and then S is equal to 0. Let's reflect a bit. So what it means, okay, this over here is the initial angular velocity. Okay. Right. So that's where with reference, theta is equal to 0. If we say what is theta, basically is the rotation of the motor. This is our theta. Theta is equal to 0. Okay. Now pulley A, okay, so this is pulley A. Okay, is given an angular acceleration alpha is equal to 0.6 theta radians per second squared. As we know, theta is in radian. Determine the speed of the block B when it has risen. Okay, so S at B is equal to 0.5 meter. The pulley has an internal hub D, which is fixed to C and turns with it. This defines that point C and D are part of a what? Which I mentioned earlier. Okay. Now, the distance x, so we know that initially s is equal to 0, right? Then now we are going to find what will happen when s is equal to 0.5. Okay. So again, this is what is given. Next come the analysis. Okay. So questions like this, you have to step back. Okay, don't don't immediately jump into the formula. Okay, my advice, don't immediately jump to formula, step back, okay, and you have to analyze. Not a lot of courses that you learn need to analyze. 2PO4, this course, okay, those who are in second year, you require a bit of analysis.